Grenton Academy, Part 6. The System Configuration Lighting. Good morning, my name is Marek Pollitt and I invite you to the next part of our training, Part 6, where you will learn how to create configuration and control lighting in the Grenton system. In the previous training video, Part 5, when creating a new project and in the step that concerned the Clu Discovery function, in a situation where there would be problems finding the Clu module, I provided as one of the remedies the possibility to reactivate the hard set function. Now, I would like to return to this function and tell you how it treats our Clu module, how we run it. First of all, the hard reset function is a function that restores factory settings, so you must be aware that after running this function, the saved configuration is deleted. The flash memory partition is formatted, and all LUA objects created are deleted. We are talking here about inputs, outputs, virtual ones, and everything that is on the Clu module. And another issue, all data from the Z-Wave controller are deleted and cleaned up as well as information about Z-Wave devices that are connected to our destination. So if you run the function when creating a new project, i.e. when our configuration is still clean, we are just starting, it will really not happen much, as the module should go back to the state in which it was taken out of the box. If for some reason you would like to run the hard set function on a Clu module that is already working, on which the configuration has already been done, then you must be aware that after a hard reset function has been completed, all configuration will be removed from the Clu module, information about all modules, both wired and wireless, in the case of wired modules. If they are connected to the system after starting the Clu Discovery function, they will be found again, while in the case of wireless modules, you will have to add them again to the controller. And now, what does this procedure look like? First of all, power should be disconnected from the Clu module. Then, there are two buttons on the Clu module, Link and Unlink. Press the first one, Unlink. Reconnect the power supply to the Clu. Then, you should see that both LEDs, which are located on the front facade of the Clu, red and green, will light and will be lit constantly. We hold the button for about 10 seconds, and after a correctly performed procedure, in about 10 seconds a 5-fold quick flash of both LEDs at the same time will be noticed. This is the information that the Clu module has been cleaned, restarted, and we can proceed to further work. Now, as I said before, if the procedure was about a new system, you just start creating a new project and you can keep working. If for some reason you performed the hard reset function on the existing project and now you would like to be able to use that project again, i.e. in 3:116, we want to send it to the same configuration again, then in the case of the hard reset function, it is necessary to first start the Clu Discovery function. At this point, the Clu module will search again for all modules that have been connected to it and will have information about them. Then it will be seen in our project that the Clu name is highlighted in orange, which means that the Clu is in emergency mode. It will be in emergency mode because it has already found all modules, but it has no configuration yet. So in the next step, after completing the Clu Discovery, it is necessary once again to send the configuration from the project, and at this point the Clu module should start working properly. Of course, if we had support for wireless modules in this project, all the Z-Wave modules should be added to the Clu controller in the next step, and the Clu Discovery function should be restarted so that working with our project can be continued. Let's move to the configuration of the system and start by identifying the inputs and outputs in the system. As you remember from the previous videos, the order of work should be roughly as follows. We start by connecting all modules to Clu modules and making all electrical connections. At this stage, of course, the project documentation is run, so we know which device has been connected to which module. Then a new project is created and the Clu Discovery function is run. All modules, all inputs, outputs find themselves in the project, and the project should look more or less in that way. So there will be Clu modules, a number of inputs and outputs, which will be displayed in a list. And now you can see that this list contains serial numbers and specific input-output numbers. So we do not have the I/O grouped in the form of devices, in the form of modules, but all the inputs and outputs from a given module are displayed as one list. And now we examine it from the very top. There is a digital in DIN module here. A number of inputs and their identification will always look the same in the beginning. So we have the serial number of the module, and at the very end the input number of this module. It will be exactly the same for the exits and other facilities. So if we have the project documentation at the moment, and we know that, for example, the switch in the kitchen was connected to the first output and the sensor from the corridor to the second input, then in the next step we proceed to naming these objects in our system, just to facilitate further configuration. And here the first important remark. If you name the objects, as in the case of naming projects, it's worth sticking to a certain pattern. This will make it easier for us to work with this project in the future, and above all will significantly speed up the configuration process. If we give these names chaotically, navigation on a large system will be very difficult. So it's worth adapting a certain pattern. For example, I use a system where I first specify what the object is, because on the tree all objects are sorted in alphabetical order. So I give, for example, a lamp initially the location of this project, i.e. bedroom, bathroom, living room, and details, as we can have more than one object in a given room. So it can be, for example, lamp underscore bedroom underscore sconce, lamp underscore bedroom underscore main, lamp underscore bedroom underscore LED, and then all these lamps will be next to each other. So later, if I configure scripts, connections with switches, I will be able to find lamps that are in the same room very quickly. Well, then we proceed to configure our project. As you can see on the screen of my computer, we have a number of devices that I have connected. Now you can see which devices they exactly are and their serial numbers. We can see, for example, the I/O 8/8 module, i.e. 8 inputs, 8 outputs. Look, its serial number. And look, we have exactly this module here, i.e. the module's serial number, 8 inputs and 8 outputs. So at this point, we're starting with the naming. I connected several devices to my system for training and presentation purposes. Among others, I have a bell switch connected, i.e. a 2-key monostable switch. I have a lamp connected to the dimmer module, a lamp to one of the relay outputs in the I/O module. Now, let's start with the switch. I know from my system that I connected the switch to the outputs 1 and 2, so that would be output 1. However, if you would like to make sure that you're using the correct input and want just to check if the input works, it's possible to do so through the built-in features. After opening, I repeat it again, double-click the object that we want to verify, and then we have the tab of built-in features. You can see the value here. The value is the current value returned by the input. So what is really connected there, what value it returns. My switch is currently off, so if I press it now, you should see the change. So we have here 1. I release and we immediately have 0. So we're able to check and verify what values we have at the input and output in the system on an ongoing basis. So if I wasn't sure whether I connected a switch to a particular input, I just need to check in the built-in features and I will know that this is actually the switch. At this point I start naming and enter the name for my switch. In my case it will be the left underscore switch, but I still have the right one connected. But before closing, we should make sure that it is connected here. We see value 0 again, we press the value 1, so everything is certainly okay. At this stage, it's worth determining one more thing, the source type of the receiver. We can determine what this object is, i.e. is it, for example, a switch, and we can immediately see that the icon on the tree changes, and here we also change to the switch and we can see already. Then I still have a lamp connected to the relay output in my system. In my case it is connected to relay output 5, but it is similar in the case of switches. We have the output state here. We can see that it is 0, but if we turn on this output and there will be nothing connected, then we will not see that this lamp was turned on. How can we check if a given output is connected or not, and how can we implement it? In the Control tab, we have a number of methods that we normally use during configuration, and which can be run from here. For example, if I would like to turn on my output, I go to Call, press the button, and you can see the light has just turned on. We also have a switch method here, i.e. we can switch to the opposite state, and we will also see that this object was turned on or off. So I already know that this is my lamp. Let's call it a lamp in the kitchen, i.e. we will have a lamp underscore kitchen. We have the only one, so I will not need to add any further information, but I have a dimmer lamp connected, and here we also have a switch method that we can call to check if the lamp is working at this time properly. It will be dimmable underscore lamp underscore living room. One small remark, when naming objects, we cannot use spaces nor Polish characters. If you want to separate names from each other, you want to insert a space, we give the so-called floor, i.e. the underscore, and we can also change the icon here similarly to the lamp. I still have an LED lamp, RGB LED lamp, so we can also check here, first of all, whether it is turned on. We set value 1, and we can also start it from this level. We can also change the color from this level, color through hue, i.e. set to 150, if we wanted to check whether all colors are working properly. Okay, so we can just turn it off and let's call it lamp underscore bathroom underscore LED. Okay, I still have an 8-button switch panel in my system, but since I only have one panel, I won't change the name. If I had more than one of these panels, I would probably be tempted to call each one of them, because then it would be much easier for me to configure. And here I will show you one more thing. The touch panel has 8 buttons. We can see it. There are 8 from 1 to 8. In the case of an 8-button panel, we will count them on a physical device from the upper left corner, i.e. 1 is the upper left button, 8 is the lower right button. But look, this touch panel has 3 more objects. We still have the object panel temperature system. Now we can check what the actual temperature value returned by this panel is. We have a light sensor that can also be used in our configurations. We see the actual lighting value at the moment, and we have something like the panel object. The panel object is the parent object that manages the entire module. In this case, it is possible to configure, for example, whether the sound should be heard after pressing the button in the case of an object. The panel will not have any more options, but it is worth looking into this object. For example, in the case of a smart panel, some additional useful functions can be found. There is another object here with the serial number of our touch panel. You can see that all these objects have the same serial number. You can see the analog object. In the analog object, you can find, among other things, information on the current voltage in the bus. So if you remember well from the movie that was devoted to powering the system, I listed there as one of the steps that always, after completing the assembly of modules and starting the system, it is necessary to check the voltage on all devices. So, in this case, it is also possible to verify such a voltage from system level of the object manager. It is worth checking to see if we have a good voltage on all devices. Okay, at the time when we have already named the objects that we will use, of course I've named only a part of them which we will use to create the configuration in this movie. But if I worked with a real object, I would start by naming all the inputs and outputs in the system before proceeding to the next tasks. More or less, after finishing this work, your tree should look like what you see on your screen now. And now we proceed to configure the switch. Let's start with a simple function, i.e. configuring the connection between the switch and the lamp. We'll take my left key, the left switch. I would like this switch to turn on the lamp, which is connected to the relay output in the I/O module. And here we now have to go back to what I said in the previous film, which is how we create the configuration in the system. If you remember correctly, the configuration in the Grenton system is based on the event-driven model. So if an event occurs, for example from a button, then we say, for this event I would like the lamp to turn on, and that's exactly what we do. So we open our switch because we always leave the object we want to control. I open the switch, we go to events, then I choose which event I would like to control in the object. In my case, I have a doorbell button. I want this lamp to turn on by clicking. So we select the on click event, then select the object from the list which you want to control. In our case, it will be lamp_kitchen, and choose how we want to control it. In this case, we will use the switch method. Switch means switching to the opposite state, i.e. if that lamp was off, it will turn on. The next time the method is called, if the lamp is on, it will turn off. Okay, we already have the switch configured, but the configuration is not done on the online controller. We create the configuration in the project, so if we want these changes we have introduced to take effect, we need to send this configuration to our CLU module. And here's another suggestion: you don't have to be present on the premises if you want to configure the system. You can appear there, perform the Clu Discovery function, download information about all the objects, and then go to the home to the office, or peacefully create further configuration for other objects. Then once we have the object ready configured, you can simply come to the customer, connect to the system, and send the configuration as I did it now. You don't have to be there all the time. You have seen now the message that the configuration has been sent correctly, so we can check at this point if my lamp is working. Do you see? I click on the switch, the lamp turns on. Short click turns on the lighting. Fine. Then let's move to a slightly more complicated configuration. In this case, one switch controls one lamp from one place. I would now like to control this lamp with two other switches. This will be my right switch, and for example the first switch in the touch panel So what do? We follow exactly the same way. So we go to the right switch, select events, the on-click event, then select the object that I want to control. It will be already illuminated automatically because we used it the last time. And OK. Then I choose button 1 in the touch panel, and also here I choose how I want to control this lamp by briefly pressing and OK. After introducing a number of changes, we send the configuration to our CLU module. You see, at this point I created a fairly simple configuration, while in the case of traditional electrical installation, performing such a function involves the need for considerable changes in wiring and the use of switches, so-called the cross ones. So if you decide to install Smart Home System, you can control any lamp with any object from any number of objects. These connections are practically unlimited. You can connect everything together in the system. Everything can be controlled. Okay, we've already sent the configuration to our system, so let's check if it works properly. The first click turned on the lamp, then pressing again caused that the lamp was turned off. And let's check the touch panel now. It works properly. Okay, let's move to some more advanced functions, i.e. dimmable lighting. In this case, we controlled the lamp, which was connected directly to the relay input in the I/O module. Now let's use the dimmer module. The principle of creating a configuration will be exactly the same. We will create a configuration in such a way that a single click turns on/off the lamp exactly in the same way as it did in the case of the relay input. But I would like, while holding the button longer, to determine the dimming value. Now you can see how we can accomplish this. So there is an event. Let's start with the simpler one. We have an on-click event in the button object. Then we select the object we want to control, i.e. a dimmable lamp, and we will use the switch method in exactly the same way as it did before. And now, so that it is possible to control its value smoothly from the level of the button, we are looking in the button object for on-hold event. Then, exactly as before, we choose the lamp we want to control, but in this case we will not use the switch method, but the hold one, and make it possible to control in such a smoother way, we need to insert the ramp time for the hold method. The ramp time for the dimmer module or for the RGB LED module will be the time between the maximum value and 0, between 0 and maximum value. So the ramp is the time that elapses from the moment of switching on until maximum value is reached, i.e. in this case, if I keep the button pressed for 5 seconds, the lamp will light up from 0 to 100% within 5 seconds. Let's proceed with the configuration. With my lamp connected to the relay output control from button number 1, so in this case we will use button number 2. Open events and, as before, start by clicking, i.e. I select the on click, I choose the dimmable lamp and the switch method. Look, we have 2 additional parameters here, time parameter and ramp parameter. The time parameter can be used if we want to turn on the lamp for a specific time. If the time parameter is set to unlimited, it means that we will switch from this lamp to the opposite, i.e. it's turned off. We will turn it on and it will be turned on. In a situation, if we enter the time here, for example, the value 3 seconds, the value is always provided in milliseconds, i.e. 3000 milliseconds. In this case, if we use the switch or switch on method, the lamp will be switched on, and then after 3 seconds it would automatically be turned off. In our case, we just want to enable it, so we set this parameter to unlimited, and we have the value of ramps. In the case of ramps, if we left the default value, we would see that the lamp will turn on smoothly for 0.5 seconds, which is quite quickly. So we will see that it will be such a soft start, but it will really start quickly. If we wanted to do so on the ramp soft start, in this case, we will enter a larger value, for example, 1 second. Then you will see that this lamp will light up very smoothly, very pleasantly to the eye. We can see how it will work. Okay, we configure the dimmable lamp with the switch method and set up a ramp of 1 second. Then we choose on hold, which is also a dimmable lamp, but in this case we will use the hold value method, and here also the default ramp for the dimmable module is 500 milliseconds, in which case the brightening would occur very quickly. To see this effect, to be able to choose a specific value, we will extend this time to, for example, 5 seconds and see how this lamp will brighten. Okay, we have already configured the button, so now we send the configuration, and after sending the configuration we verify how it works. Button 2 or a single click should now turn on the lamp. You see the lamp brightens a little longer than normal. RTO is the effect of using this 1 second lamp. Then a longer hold should smooth and darken it for us, i.e. press and hold, and you can see now how this lamp brightens. If we release this button at any time, the value we have set will remain. Can you see it? And again, we can brighten, stop and darken, and stop now. In this way, we can smoothly set the value of the lighting that we want to achieve. Another click should turn off the lamp. Okay, let's move now to the configuration of the RGBW LED module, and here we have a configuration that will allow us to change the color smoothly and turn on and off this LED lighting. In fact, the configuration will look exactly the same as it was in the case of the dimmer module or relay module. In general, the configuration in the system will always look very similar. It is important to know how we use these events, methods, and what the methods and events mean. You can find information on how they work in the Object Manager. Now look at the screen. After highlighting the method with the mouse, you will see information on how it will work and how it will be exactly the same for built-in events. But you will also find all the information in our documentation or instructions on our website. In the case of LED lighting, i.e. the RGB module, which I will configure in a minute, I would like button 3 in my touch panel to switch the lighting on and off briefly, while for a longer holding, change the color of the lighting. If you click, you do it exactly the same way as it did in the case of the dimmer module, the switch method, i.e. one click will turn on, the next one will turn the lighting off. However, if we change the color, we will use the hold hue method here. For the RGB LED module, the color can be changed in 3 ways. First, by hold hue. With the help of hold hue, we can choose any color from 0 to 360 that we like according to the HSV palette. You can see what the HSV palette looks like on the internet. We can also control the color using the RGB channels also separately, i.e. for each of these channels we can set the color value, and which will be interesting for us, but we can also provide the RGB color value in the so-called graphic code, i.e. we provide it via the hashtag RRGGBB. In this way, you can also choose any color palette you want to achieve in your system and enter into this module. In our case, we will use the hue palette method, i.e. hold hue. Okay, in this case, we proceed to the configuration. I select button 3 and also go straight to the events and we will start with the on-click event. My LED lamp will switch its state, i.e. I choose the switch method, I leave with the unlimited parameter and default ramp to quickly see the changes, and take the hold method, but the hue one. In the case of the RGB LED module, we can also dim and brighten, as was the case with the dimmer. And here we also set a longer ramp. If we set this ramp very short, then the value would change smoothly. But within this specific range, for example 0 to 500 milliseconds, if for example we set the value here, for example 5 seconds, i.e. 5000 milliseconds, then we will be able to see how the value changes smoothly. After configuration, we send the configuration to the CLU module, and here in the meantime I would like to give you another small digression. Because we work with a Windows environment, certainly many of you have already encountered a system crash. If we create such a configuration, especially a larger, more complex one, let's save it during work. We can do this by opening the File tab and saving the project. But as you can see, the keyboard shortcut Ctrl+S also works here, which means I can run it now, and this project will be saved. Especially if you make a lot of changes at once. Before you send it to the configuration, i.e. you are working offline, doing it at home, try to save these changes as often as possible so that you don't get any nasty surprises and have to enter them all again. The configuration was sent, it was our button 3, so let's check it now. Single click, the LED lamp has been switched on, and now we press and hold and see that the color changes smoothly, and when the button is released, this color will be set to the one we have set. Okay, turn off the lamp and configure the system further. At this point you already know how to create basic connections or how to connect outputs with inputs. You can configure your systems in exactly the same way. Now let's get to the scripts, i.e. scripts in the Grenton system. Let's start with a script, maybe not so much basic but very popular, i.e. turn off everything. To create such a script, go to the Object Manager and see the scripts under CLU. Add a new script, enter the name, for example, scene underscore switch off underscore all, and the script builder tool opens with the start field marked. On the right you can see the tray with the components. Creating a script now is simply that we catch the component that we want to use, throw it into the workspace, now select the object that we want to control, i.e. the lamp in the kitchen and the methods we want to use. Because we want to create a script that is a scene that will turn off all our lamps in our home in the system, so we will use the switch off method. Okay, we added the first one, then another action and the next lamp, i.e. the LED lamp, and choose the same method, i.e. switch off. Then the dimmable lamp will be added and the switch method as well. Now you can see that in this script connections start from the start field. Then there is a line ending with an arrow to the first one, next one and the following one. At the moment when the script is run, all these actions will take place virtually simultaneously. The house members nor us will be able to see which one was done first, which was the next one. Time between calls of subsequent instructions will be really very fast. However, these actions will be performed sequentially in the system and one by one, and this line, this arrow, tells us which order will be executed in which sequence. This is especially important when creating more complex logic, and it's about letting us know which action follows which one. If we have already created our script and it is finished, we would like to call it now. In the case of the Grenton system, this script is not called by itself, it is not connected to any loop, and we do not need to call it with any interruptions. In order to make the system created in that way run, we treat it in exactly the same way as if it were the lamp method, i.e. as we configured the button and choose the lamp and then set turn on, exactly in the same way we treat the scripts, i.e. choose the button in the panel touchscreen, for example in button number 8, we choose which method should run the script, let it be the on-click method, and then find the scripts on the list of CLU methods. So we select the CLU module and you can see here we have created the scene. Okay, I mark, add, see that I made a small typo in the name of this script. Now with the on-click method I have added a name. So to change the name for the script, we enter the script, its parameters, and we can change the name here. Okay, so I repeat again. If we already have created a script, I choose the button that I would like to control it, then the event I would like to run it. I highlighted CLU and you can find my script or the script that you open. You will find on the list of methods for the given CLU. We click OK, send the configuration, and afterwards we will be able to check how it works. We turn on all the lamps now. We have attached a lamp connected to the relay outputs, a dimmable lamp, and a lamp connected to the RGB LED module. And in this case, pressing will simultaneously turn off all the lamps. Okay, let's do another script now, a little more complicated. In this case, we have created a simple script that will simply turn off the lighting in the whole house. Let's make the lighting turn on sequentially, then turn it off sequentially. We create another script. Let's call it scenario_input. And now we add the first lamp. This will be the kitchen lamp. We will turn it on and see on the component side we have something like a function block. After adding this block, we can add a delay or delay from the list and enter the value, for example 1 second, i.e. 100 milliseconds. We can now enter another action, our dimmable lamp, turn on, OK. On the component side you can see another very nice component, condition. In the next step, we will add the next function to see the delay this time. Because in the case of the dimmable lamp, we have a switching time of 500 milliseconds, we will apply a little longer delay, for example 1500 milliseconds, and add a conditional instruction. The condition works like if in programming languages, i.e. if something, do something. When adding a condition, in the first step, we determine what characteristics we make its implementation dependent on. In this case, we make the next instruction dependent on time. We can also check the current time on the CLU method list. We select the time. So if the time is over 12, turn on the LED lighting, which is lamp_LED switch on, and maybe it would be more interesting to turn this lamp on and see. The script will be run 1, 2, 3, 4. Instructions will be executed. Then we come to the conditions. At this moment the system will check what time it is. If the time is over 12, we will go to the true branch and the instruction will be turn on the LED lamp. If the time were before 12, nothing will happen in the configuration as it is now. However, if we wanted something to be realized and something happened, in this case it is possible to add another instruction and, for example, we want to turn off such a lamp. And one small remark here, the system will always tell us the connection from the last component. So when adding another instruction to a condition, we have to delete that line. Select it and click delete. Then click the connection tool from the above component, click on the condition and click on the instruction we want to connect to. Now see, we run our script. The first instructions will be called. We come to the condition and check. If the time is over 12, turn on the LED lamp. If before 12, turn off the LED lamp. Certainly, we can continue to add further instructions here. For example, turn on the LED lamp and set the color or set hue to red. And once again, remove the line, catch the tool, drag and connect with each other. And if it is before 12 o'clock, in this case, we turn the lamp off. So there is no point in setting any color. We have the script, send it, and before that we can connect it. The disable everything stage has been connected to key number 8. So in this case, we connect the script to key number 7. And just like before, select the on-click event, look for the entry scene on the CLU method list, and send the configuration. And now, after sending the configuration, I press button 7 and see the first lamp, dimmable lamp and LED lamp have switched on because it is already after 12. What is the current time? If you open the properties of the CLU module and enter its built-in feature, you can see here what the current time is on our CLU module, and all the features that you see here you can also use when creating the other scripts. Fine, we can create scripts in graphical editing, and you can build your own control algorithms in such a very transparent and clear way. But if you would like, let me put it in colloquially, to winkle out more from the system, you can always go to text editing, and now you can see how this script will look like in LUA. And here we can write script language, LUA language, our scripts, our configurations. One small thing, if we go to text editing and want to make some changes, it will no longer be possible to return to graphic editing. So you have to be sure that you want to do and go to text editing. Of course, we will be warned before we make any changes, so we can always come back. Until we make such changes, there is always the option of returning to graphic editing. That's what we've prepared for today's episode. I invite you to the next parts where you will learn how to prepare interfaces for mobile devices and also how to control heating, blinds and other system elements. Thank you and see you then.